Okay, section 20.2, dealing with the same equations we talked about yesterday, redox reactions. Today we're going to take these reactions and we are going to balance them. Okay, and we're going to use what are called half reactions to do so. Okay, before we get started on this is what you might find on an AP exam, where you have a reaction such as this above, and they want to know what are the true statements. So we might want to look at this reaction. Obviously they're talking about this being an oxidation reduction reaction. So let's look at what they say. They say copper acts as an oxidizing agent. If it acts as an oxidizing agent, then it must be reduced. Here, copper's in its elemental form, therefore it starts as a charge of 0. On this side it goes from 0 to plus 2. If it goes from 0 to plus 2, it means it had to have lost 2 electrons. If it lost 2 electrons, then it is being oxidized. So therefore it cannot be an oxidizing agent. It must be a reducing agent. Okay. Number 2 says the oxidation state of nitrogen changes from plus 5 to plus 2. On this side the oxygen is minus 2 and there's 3 of them, so that's minus 6. Therefore the charge on nitrogen must be plus 5 to get back to our negative 1. So that part is right. On this side, oxygen is negative 2. Therefore, nitrogen must be plus 2. So yes, it does go from plus 5 to plus 2. So we can see that in this case, here it's going from plus 5 to plus 2. So the copper is being oxidized. The nitrogen is being reduced. Taking that into account, number 3, hydrogen ions are oxidized to form H2O. No, here hydrogen is plus 1. On this side, hydrogen is still plus 1. Hydrogen ions are not being oxidized. So the correct answer is B, 2 only. Okay? So that's some information from yesterday, what you might find on your last exam. Okay, as we know that when we balance equations, we have to obey the law of conservation of mass, that the elements must be the same on both sides. But we also have to take into account when we're doing redox reactions, remember that, like for example this reaction here, the number of electrons on both sides must also be the same. So if copper, as we said, loses a certain number of electrons, nitrogen must gain that same amount. So with redox reactions, the electrons must also be balanced. So if a substance loses a certain number of electrons during a reaction, then another substance must gain the exact same number of electrons. Okay, and the way that we do that is we do that by splitting the reaction up into 2 parts, which are called the half reactions. So we're given a reaction, and the first thing we want to do is we want to split it up into 2 separate reactions. We want to split it up into one reaction that shows the oxidation, the other one that shows the reduction. So in this case, we have a reaction. The first thing we have to determine is what's being oxidized, what's being reduced. So we can see that tin is going from a plus 2 charge to a plus 4 charge. So the way that we write that is Sn2 plus becoming Sn4 plus. When that happens, notice that it loses 2 electrons. When it loses electrons, we write the electrons as the products. The iron, on the other hand, is going from a plus 3 charge to a plus 2 charge. When that happens, we're gaining 2 electrons. So here we can see 2 electrons being gained. And these are what's called the half reactions. Okay, as you can see, when something's being oxidized, the electrons are shown as products. When things are being reduced, they're gaining those electrons. The electrons are being shown as reactants. Okay, and like I said, the number of electrons lost must equal the number of electrons gained in the process of the oxidation and reduction. Okay, so how do we do it? Okay, first of all, like I just said, you convert the entire process into 2 separate processes, oxidation and reduction. Then you balance the elements other than hydrogen and oxygen. If it doesn't have hydrogen and oxygen, then don't worry about it. Just balance don't worry about the hydrogen and oxygen at all. Okay, for both processes. Then if there's oxygen atoms, you balance the oxygens by adding water to both sides. To the side that needs it to balance the oxygens. And then you balance the hydrogens by adding H pluses to the other side. Okay? And then you look at the total charge on the left-hand side, the total charge on the right-hand side, and those also have to be the same. And the way you make them the same is by adding electrons to either the left side or the right side to make them the same number. Okay, then if you're in an acidic solution, you're done. No other change is needed. That half reaction is now balanced. However, in a basic solution, for every hydrogen that you added up here in step 3, you add an OH to each side of the equation. And so basically what you're doing is you're going to be turning the side that has the H pluses into waters, and you're going to be adding OHs to the other side of the equation. And then the number of electrons gained have to equal the number of electrons lost, so you have to multiply each equation by an appropriate number so the electrons come out to be the same. Then you just add the two equations together, and everything should cancel that needs to be canceled, and then you have your balanced equation. This is much more involved than simply balancing a regular old equation. So let's take a look at it, huh? So we have MnO4 minus, a permanganate ion, reacting with the oxalate ion, C2O4 2 making a manganese ion plus some carbon dioxide that's dissolved in the water. So we want to split this up into two different reactions. Obviously the Mn has to stick with the Mn, and the C2O4, the C has to stick with the C. So we're going to split this up into two separate processes, the oxidation part and the reduction part. And it really doesn't matter if you call them oxidation reduction, but you have to split them up into two different processes. So one of them, MnO4 minus, is becoming Mn2 plus, and in the other reaction, C2O4 2 minus is becoming CO2. Again, why is it reduction? Here manganese is plus 7, here manganese is plus 2. On this side, the oxygen's minus 2, there's 4 of them, that's minus 8. We got to get back to negative 2, so this has to be plus 6. So each carbon is plus 3. Over here, the oxygen's minus 2, and there's 2 of them, so that's minus 4. The carbon has to be plus 4. So the carbon goes from plus 3 to plus 4. It lost another electron, so that is oxidation. Manganese gained 5, it's reduction. Okay, and now we're going to balance the elements other than hydrogen and oxygen for both processes. In this case, there's one manganese on the left-hand side, one manganese on the right-hand side. That's already balanced. Okay, for C2O4 2 minus, we have 2 carbons on the left-hand side, only 1 carbon on the right-hand side. So we make 2 CO2s, and now the carbons are balanced. Okay, so this one there was nothing else we had to do. This one is now balanced that way. Step 3, now we're going to balance the oxygen atoms by adding water. So in this case, we've got 4 oxygens on the left-hand side. We have to get 4 oxygens on the right-hand side. So we add 4 waters to that side. Yes, it screws up the hydrogens, but we'll fix that in just a second. Okay, now we've got 8 hydrogens all total on the right side. So to balance those out, we have to add H pluses to our left-hand side. So overall, we have 8 H pluses, MnO4 minus, Mn2 plus, and 4 H2Os. Okay, now we have to look at the charges on that left-hand side. We have a total of 8 positive charges. So that gives us a charge of plus 8. There's only one MnO4 minus, so that's just a minus 1. So overall on the left-hand side, our charge is plus 7. On the right-hand side, we just have one Mn2 plus. So therefore, the charge on the right-hand side is plus 2. To make those the same, all we can do is add electrons. To add electrons to the right side or the left side is the question. Well, we want to make these two numbers the same. By adding electrons to negative 2, it's just going to make it negative 1, 0, negative 1, 2, 3, and so forth. If we add electrons to this side with the plus 7 side, now we're making it negative or positive 6, positive 5, positive 4 until we get down to positive 2. So we're going to add 5 electrons to this side. That adds 5 negative charges. By doing so, that makes that left side equal to positive 2. So we have 5 negatives, the 8 positives, and the 1 negative here makes our total charge plus 2, and then we've still got our plus 2 on this side. Okay. So we have to do the same thing for the reduction reaction. So if we come back to this one here, we have to balance our oxygens first. We have two CO2s. That makes 4 oxygens. Well, here we already have 4 oxygens. Well, there's no hydrogen to balance then because we didn't add any waters. So all we have to do now in this case is just balance the negative charges. So if we have -2 on the left-hand side, we have to have the -2 on the right-hand side. So all we have to do to that reaction is add our 2 electrons. The oxygens were already balanced, therefore we don't have to add any hydrogens. So now we have a balanced equation of -2 and -2. Okay, now we have to look at our 2 half reactions. This side, 5 electrons are gained. On this reaction, 2 electrons are lost. They must be the same. So therefore, we take our whole top reaction and we multiply it by 2. And we take our whole bottom reaction and we multiply it by 5. And therefore, we'll have 10 electrons here, 10 electrons gaining, 10 electrons being lost. So our equation becomes that and that. Now, anything that is the same on both sides, we can cancel out. So we can take our 10 electrons and our 10 electrons and cancel them. The H pluses, I don't see any H pluses. H2Os, I don't see any H2Os. Many times there are, and you could cancel. Like say there were 16 H pluses here, and say there were 8 H pluses over here. That would cancel all 8 of these and then 8 of these ones. But since we don't have that, nothing else cancels. So our overall equation is that whole mess right there. The only thing that ended up canceling were our electrons. Okay, and that is your balanced equation. If you've done that correctly, the electrons are going to cancel, but the charges should still be the same. You have 16 positives, 2 negatives, and 10 negatives. What does that make? Positive 4 all total. 5, negative 10, negative 12, and positive 16 makes positive 4. And over here we have 2 pluses. That's positive 4, no charges here. So positive 4, positive 4. Okay, so here's another example here where we have Cr2O7 reacting with Cl- to make Cr3+ and Cl2. Okay, we want to do the same thing as we did on the other one. You can pause it right now and you can try it yourself, or you can just sit there and just look at the answer and hope you learn it by osmosis. Okay, try that out. You should be able to get this answer here. If not, then then I can do it tomorrow in class. Okay. Now, in a basic solution, I don't think I showed this one out, but let's go ahead and do it together here now. This other one was an acidic solution, so that you'll do the exact same way as the other one. But in a basic solution, let's look at how we would do that. So our 2 reactions, first of all, are Cn- becoming CnO- and MnO4- becoming MnO2. Okay, so first of all, we want to balance things that aren't oxygen or hydrogen. So the carbons are good, nitrogens are good. Now we want to balance our oxygens, so we're going to add an H2O to this side. And by doing so, we added 2 hydrogens, so now we have to add 2 H pluses to this side. Okay. Let's do the same thing down here. The manganese are already balanced. There's 2 oxygens here, 4 here, so we need to add 2 H2Os. When we add 2 H2Os, we now need to add 4 hydrogens to the other. Our 4 H pluses here, and so now we've got our oxygens balanced, our hydrogens balanced. But remember, now we're in a basic solution. So for each side where we added a H+, we also have to add that many OH minuses. So now to this reaction, we're going to add 2 OH minuses, and to this, and we have to do the same thing to both sides. So we're going to add 2 OH minuses to this side. Same thing down here. We have 4 H pluses, so we're going to add 4 OH minuses to this side, and we also have to do the same thing as 4 OH minuses. And basically what that does is it turns this part right here into 2 waters. Well, we've got 2 waters here. We've got 1 water on this side. So that's going to cancel out that one water and one of our waters over here. And then over here, we've got 4 H pluses, or excuse me, 4 OH minuses. I think that's OH minus. Yes, it should be. It's very hard to read. I'm sorry. But that's 4 OH minuses and 4 H pluses. That makes 4 waters. Here we've got 2 waters. So of our 4 waters that we have here, 2 of these 2 cancel out. 2 of these cancel out. So we have 2 H2Os over here. Okay. So overall, now we can start looking at charges. So on our first equation, we've got -2 right here. We've got another negative right here. So we have a total of -3 on our left-hand side. And on the right-hand side, this is gone. That became our water. We've got a -1, and we've got a water, and that's it. So we need, if we've got -1 over here and -3 over here, we need to add 2 electrons to this side. By adding 2 electrons, that gives us a charge of -3 on the right-hand side, -3 on the left-hand side. On our bottom one here, we've got our 2 waters. We've got our MnO4 minus, that's a -1. Over here, we've got -4 from our 4 hydroxides. And so overall, we need to add 3 electrons to this side. So 3 electrons here makes it a total of -4 on the left-hand side, -4 on the right-hand side. Notice that when you do this correctly, there will always be electrons on one side and electrons on the other side. You'll never have a case where the electrons are on both sides of the equation, because that means that either they're both being lost or they're both being gained, which is impossible in an oxidation reduction reaction. So now we can take this equation here and we go, okay, 3 electrons gained, 2 electrons lost over here. We have to make them the same. So this whole thing we're going to multiply by 3. And this whole thing we're going to multiply by 2. So overall, we are going to have 3 times 2 is 6 OH minuses plus 3 CN minuses, producing 3 CNO minuses. And remember, we had this water left up here, plus 3 waters plus 6 electrons. And then for our second equation, we were multiplying this whole thing, what do we say, by 2? Yes. So that makes, on our left-hand side, 6 electrons. 2 times our 2 waters makes 4 H2Os. 2 MnO4 minuses, producing 2 MnO2s. Again, pause as you need, rewind as you need. Those waters are gone, plus 8 OH minuses. Okay, and then overall, before we combine them all together, we can cancel things. So 6 electrons, 6 electrons. 4 waters and 3 waters. These 3 waters are gone. Those 4 become 1 water. And then we've got 6 hydroxides here, 8 hydroxides here. So those 6 are all gone. And this 8 becomes a 2. So overall, on our reactant side, we should have 3 CN minuses, an H2O, and is that 2 MnO4s? And our product side, we should have 3 CNO minuses, 2 MnO2s, and 2 OH minuses. Unfortunately, once I put the answer back up here, this is all going to erase. So it should be 312 and 322. 3, 1, 2, 3, 2. 2. Good. That means we did it right. And I'm glad. Because you can tell that's not very fun. I mean, maybe for you weirdos it's a little fun, but that is definitely much more involved than a typical reaction. So how might you see this on the AP exam? They might give you a whole reaction such as this. And they'll say, when this equation is balanced and all their coefficients are reduced to the lowest whole number terms, what's the coefficient for H+? Now, what you might find is you might be able to balance this just by normal ways. 1 magnesium, 1 magnesium. 1 nitrate, 1 nitrogen, 1 nitrogen. 3 oxygens, 1 oxygen. So you need a 3 here. And then when you do that, then you can go, okay, 4 hydrogens, 6 hydrogens, 10 hydrogens. Now that might work. However, if you look at charges, let's see if it actually does. Here you've got a -1, and here you've got a +10. So that gives you a total charge of +9 on this side. On our right-hand side, we have a +2 and a +1. That makes it a +3. If the charges don't match, then the equation doesn't work. The answer to this question is not 10. And so what you have to do is you have to go backwards. You have to take out this H+, take out that water, and start over and make your 2 reactions where you go Mg makes Mg2+, and NO3- becomes NH4+. That's the only way you can figure out what that coefficient for hydrogen is going to be. So you have to balance the whole thing. You have to do basically everything that we've already done. So you have to add the oxygens to this side, the hydrogens to this side, balance the charges, add them all together, and there you'll get your coefficient for hydrogen. Figure that out and tell me what the answer is tomorrow. Okay, so half reactions, redox reactions can split into 2. There you go. Again, most of these are free response or multiple choice type questions. So if you would please, these are questions out of the book, please look over them, do them. We'll talk about it tomorrow in class. Stuff you definitely need to know when we're getting to the more difficult stuff. Unfortunately, there's just not a lot of free response questions involving this.